Hi everyone, Tina here, and today I'd like to talk about differentiation. Differentiation is a branch of calculus and it's a huge topic in the A-level course. In this video, I'll run through the basic ideas about differentiation that you'll need to be familiar with. You'll need to be confident with these ideas before you can then build on your knowledge later in the course. So let's start with what is differentiation. When you first learn about differentiation, you'll come across the idea of dy over dx pretty quickly. At a high level, dy over dx is related to delta y over delta x, which in turn is related to change in y over change in x. And you may recognize this as being one of the formulas for calculating the gradient. So differentiation is really a tool for calculating the gradient. Sometimes you will have functions defined as y equals something. And in this case, you usually write dy dx equals when you differentiate. But other times you'll have f of x is equal to something, and when you differentiate that, you can write f dash x. Either way, both of these things mean the same thing, they're just slightly different notations, and both of these can be referred to as the derivative. So now we know a bit about the notation, how do we actually differentiate something? I'll show you the general rule now. So if you have a function that looks like this, y equals ax to the power of n, so something x to the power of something, the general rule is dy dx is equal to nax to the power of n minus 1. So what's happening is you're taking the power of x and you're bringing it down to the front and multiplying. You're then reducing the power by 1. So if I do a basic example on the side, let's say we've got y equals 3x to the power of 5. If I want to differentiate this and do dy dx, it will be 15x to the power of 4. Because I'm bringing that 5 down and multiplying it by the 3 to get 15. And then I'm reducing the power by 1 from 5 to 4. And that's it. Now let's work through some more interesting examples. Example 1, y equals 2 over x cubed plus 8 root x minus 4x plus 2. Find dy dx. So I recommend that you start by rewriting y to be in a format which is going to make it easier to differentiate. So for this one, I would write y equals 2x to the power of minus 3 plus 8x to the power of half minus 4x plus 2. So this is just rewriting the algebra as powers of x rather than as fractions or roots. Once you've done this, you're ready to differentiate. So dy dx is going to be minus 6x to the power of minus 4. And that's coming from bringing that negative 3 down to the front, multiplying by 2, and then reducing the power by 1, plus 4x to the power of minus a half, doing the same thing there. So bringing the half down to the front, multiplying it by 8 to get 4, and then reducing the power by 1. And then for minus 4x, this actually just becomes minus 4. The reason for this is, if you think about minus 4x, that's the same as minus 4x to the power of 1, because an x on its own can have an invisible power of 1. So if you were going to differentiate that using the method we just spoke about, you would bring the 1 down to the front and multiply it by the minus 4 to get minus 4. And then you would reduce the power of x by 1 to get x to the power of 0. X to the power of 0 is 1, so you end up with just negative 4. Now, if we think about this plus 2 on the end, when you differentiate that, that actually disappears. The reason for that is because if you have 2 on its own, you could think about that as 2x to the power of 0, because x to the power of 0 is 1. Once again, if you then do the differentiation general rule, bring that 0 down to the front and multiply, you get 0. So it would be 0x to the power of minus 1 if you reduce that power as well. And that's just the same as 0. So when you differentiate, any constants will disappear. So this is technically our final answer, but if you want to, you could rewrite it to be in terms of fractions and roots again. If we did that, it would be minus 6 over x to the power of 4 plus 4 over root x minus 4. Example 2, f of x is equal to 3x to the power of 3 over 2 plus 3 over x squared minus 6x. Find f dash of x. So again, let's start by writing f of x in a form that's going to make it easier to differentiate. So 3x to the power of 3 over 2 plus 3x to the power of minus 2 minus 6x. Remember, f dash x just means differentiate, or the derivative. So when we do that, we're going to get 9 over 2 x to the power of a half. Bring the 3 over 2 down, multiply and reduce the power by 1. Minus 6 x to the minus 3, doing the same method. and then minus 6 on the end. And that's it. Example 3, f of x is equal to x squared plus 3x minus 10. Find the gradient of f of x when x equals 1. So this question doesn't reference differentiation, dy dx, or f dash of x. It only references the word gradient. So you need to be aware that that means you need to differentiate, because dy dx or f dash of x both mean the same thing really, and that's the gradient. So if we find f dash of x in this case, it's going to be 2x plus 3. And then they want to know the gradient when x is equal to 1. So all you need to do is substitute 1 in for x. So when x equals to 1, f dash of x is going to be 2 times 1 plus 3, which is 5. And that's it. Now, it doesn't say that we need a sketch for this question, but I just want to show you a brief diagram of what's going on here. So f of x is just a quadratic here, x squared plus 3x minus 10. If we factorize that, that's going to be x plus 5 and then x minus 2. Make it equal to 0 to find the roots, and you get x equals negative 5 or 2, meaning it would cross there and there. We draw a rough picture of what that would look like for a quadratic, maybe something like this. Y-intercept at negative 10. We just found out that when x was equal to 1, the gradient was 5. So let's just sense check that. If 1 is around here on the sketch, so around here on the curve, it does in fact look like that the gradient of the tangent to the curve at that point would be positive and fairly steep. So a gradient of positive 5 does make sense there. Last example, y equals 2x squared minus 5x plus 3 all over x. Find dy dx. So for something like this, you want to split up that fraction into 3 separate components. I'll show you what I mean. So make it 2x squared over x minus 5x over x plus 3 over x. We can do that because that's just the reverse of adding and subtracting fractions. And the reason that's a good idea is because you can then simplify each part separately. So we could cancel an x from the top and the bottom there, could cancel an x here and here, which means y is actually equal to 2x minus 5 plus 3x to the power of minus 1. This makes it a lot easier to differentiate. So when you do dy dx, you're going to get 2 from 2x, minus 5 disappears, and then the last term is going to become minus 3x to the minus 2. Part B, find the gradient when x equals 3. Again, because dy dx is the gradient, all we need to do is sub x equals 3 into dy dx. You can just type that into your calculator, and when you do, 5 over 3 would come out, and that's the final answer. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.